Most AI experts tell you to trust the output if it passes the tests. They're wrong. For senior engineers, that's exactly how you introduce critical security vulnerabilities into production. See, AI doesn't understand your architecture, it understands patterns. And sometimes, it patterns in a disaster. I've spent over a decade leading engineering teams and reviewing thousands of PRs. I've seen the perfect Copilot suggestion bypass a security layer or create a memory leak that only triggers at 10,000 concurrent users. I've lived the 3 a.m. incident reports caused by efficient AI code. Today, we're moving beyond the hype. I'm giving you a senior engineer's framework for auditing AI-generated code. We aren't talking about syntax or indentation. We're talking about security, scalability, and long-term maintainability. By the end of this video, you'll know how to leverage these tools without turning your codebase into a liability. Let's get into it. You're cruising. You prompt, it generates, you hit run. The tests turn green. You feel like a 10x developer. But here is the cold truth. Green tests don't mean the code is correct. They just mean it didn't break the specific scenarios you remembered to write. For a junior, that's a mistake. For a senior engineer or a tech lead, that's a liability. See, AI doesn't understand your architecture. It understands patterns. It'll give you a solution that looks elegant, follows the style guide, and passes the unit test, while introducing a subtle race condition or a catastrophic SQL injection. Or worse, it hands you a function with ON squared complexity that works perfectly with your 10-row test database. Then it hits production. Now your latency is spiking, your pods are crashing, and you're the one explaining to the CTO why the AI-optimized feature just took down the entire API. You aren't just shipping code anymore. You're shipping invisible technical debt that you didn't even write. And the worst part, because the AI wrote it, you're less likely to scrutinize it. That's exactly how the most expensive bugs in your codebase are born. Here is the reality: AI isn't a coder, it's a high-speed pattern matcher. To use tools like GitHub Copilot or Cursor AI at a senior level, you have to stop treating them as assistants and start treating them as junior interns who lie with absolute confidence. The solution isn't to stop using AI, it's to implement a zero-trust audit framework. You don't ask, does this work? You ask, how does this fail? First, let's talk about the happy path trap. AI is optimized for the most common solution found in its training data. It loves the happy path. But senior engineering is about the unhappy path. If your AI-generated code passes your unit tests, that doesn't mean it's production ready. It just means you didn't write a test for the edge case the AI ignored. Next is the security blind spot. AI often suggests the most convenient library, not the most secure one. It might introduce a deprecated package, or worse, a pattern prone to SQL injection because it saw that pattern in a 2018 Stack Overflow thread. This is where you integrate a dedicated security layer. Use Snike or similar static analysis tools to audit the AI's suggestions. Never let AI-generated code hit your main branch without a security scan, period. Then we have the scalability debt. This is the silent killer. AI will happily write a nested loop that looks elegant and works perfectly with 10 rows of test data. But when that hits a production database with 10 million rows, your latency spikes, your memory leaks, and your on-call phone starts ringing at 3 a.m. You must audit the big O complexity of every AI suggestion. If the AI can't explain the time and space complexity, you shouldn't be merging it. So, what does the actual audit workflow look like? Step 1, prompt for failure. Don't just ask for the code. Ask, what are the 3 most likely ways this implementation will fail in a high-traffic environment? Force the AI to argue against itself. Step 2, the manual trace. Step through the logic without reading the AI's comments. Comments are just more patterns. The logic is the only truth. Step 3, boundary stress. Push the inputs to the extreme. Empty strings, massive payloads, unexpected types. If it breaks, you've just saved your company from a critical outage. Now, I'm not saying scrap the tools entirely. When you actually audit the output, tools like Cursor or Copilot become force multipliers. But speed is useless if you're shipping vulnerabilities. That's why I integrate Snike into my pipeline. It catches the critical security gaps that AI blindly ignores before they ever hit production. The result? You get the velocity of AI with the reliability of a senior architect. You stop firefighting and start scaling. If you want to build a professional, AI-driven workflow that won't get you fired, check the links in the description for the tools I use. If this shifted your perspective on AI code, hit the like button and subscribe for more senior-level engineering deep dives. Now go audit your PRs.